defining what exactly is a factor. The best way to do this is to think about what it means to divide evenly. Take for example 20 divided by 5. We get an answer of 4 with 0 remainder. So this means that divides evenly. Next, let's try to think about 20 divided by 3. It's easy to see that this leaves an answer of 6 with remainder 2. Since there's a non-zero remainder, this means that it does not divide evenly. So pretty much from here, we can get a vague definition of a factor, meaning it's a number which divides the other one evenly. So that means 5 is a factor, but 3 isn't a factor of 20. So now that we somewhat understand what it means to be a factor, I have a thought question for you. Is 1 a factor of every single number? Please think about that for a minute, pause this video, and let's talk about it. So now that you've thought about that, that actually makes a lot of sense. Because if you divide any number by 1, you always get that number itself. Like a number divided by 1 is equal to number with the remainder 0. Because of this, it's actually fair to say that 1 is a factor of every single number. This is very useful to us, since this will actually bring us into our next topic of what is a factor tree. So a factor tree is pretty much a list of all the factors in a number. For example, let's start working through what a factor tree of 20 is. So I'll draw 20 on the top of our tree, and let's start listing out the pairs. So what I do is I try to go from 1 all the way to the number as I list out the factors. So I'm like, okay, is 1 a factor of 20? The answer is obviously yes. Dividing 20 by 1 gives us an answer of 20. Next number, 2. Is 2 a factor of 20? Yes, it is. It gives us an answer of 10 with the remainder 0. Now, is 3 a factor of 20? We saw that doesn't work. So pretty much, we just skip it. Now, is 4 a factor of 20? Yes, it is. It gives us 5 with the remainder 0. Now look at this. You would notice that 5 is also a factor of 20. And by dividing it, you get 4. But do you guys notice anything similar about these two items? You see that they're just reverses, meaning that they're adding nothing new. So pretty much, once you reach the number already on this side of the column, you just cut it off. So our factor tree of 20 would have everything except that. So everything in our dotted box is in the factor tree of 20. So just keep that in mind. As we're going from 1 all the way up to the number 20, the second it reverses, we call it a day and we've made the entire factor tree. So now, let's try making our own factor tree, since we already know how exactly to do it. So the exercise will be, can you guys create me the factor tree of a number 36? So I'll give you guys a minute to do this. Please pause the video and we'll discuss soon. Okay, so now that we've tried to make the factor tree, let's work through it together. So starting with 1, we see that 1 always is a factor, so that will be our first branch. Then our next one will be 2, since that also divides, so 2 times 18. Then 3 also divides, 3 times 12. 4 also divides, 4 times 9. 5, it does not divide, it relieves the remainder of 1. So then we'll move on to 6, and that divides. And wow, isn't that interesting? We have 6 times 6. We have the same number. So when we're going to be counting the factors, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 factors, instead of 10 factors, which are the number of numbers present in the tree, since this one is repeated. Wow. So this is actually common because 36 is a square number. It's actually equal to 6 squared. So pretty much on the last branch of the factor tree, the number would repeat. So that's when you know how to stop and how to know that you shouldn't double count the factors. So to recap, in this video, we learned what exactly a factor is, then how to systematically make a factor tree by starting at 1 and ascending up to the number, and stopping once a reversal happens, or in this case, a repetition happens. And then we also learned something special about square numbers, how they have an odd number of factors, and they also have this repeat in their last branch. So I hope you learned a lot from this video, and this will actually help us lead into our next topic of prime numbers. So please stay tuned, and thank you for listening to this video.